Hello, my name is Lane, and today we're going to be speaking about carbon-based ceramics and learning a little bit as far as just what ceramics are in general, some of the processes as far as how it's refined, how it's come about, and then some finished products. So ceramics and kind of what are they just in general? They are inorganic and non-metallic materials that are produced by natural or synthetic substances when consolidated under high temperatures, ultimately to achieve strength, durability, and/or any desired properties, depending on what is needed. It consists of hard, brittle, and heat-resistant materials, which are obtained by processing raw materials consisting of clay, minerals, and other inorganic compounds at very high temperatures. Ceramics are extremely resilient to breakdowns, even under some of the harshest conditions, which earlier mentioned, under extremely high temperatures, and just how they're just resilient to that kind of stuff in general. Um, this is just a quick property and use data table on some of the materials that are used in ceramics and advanced ceramics. Those include these four, which will be alumina. Some of the primary uses you'll get electrical insulation, biomedical implants, chemical equipment. Zirconia, which will used in cutting tools, dental implants, jewelry, thermal coatings. You'll have boron nitride, which is also used in electrical insulation. So some of those ceramic materials, they'll kind of be shared between things depending on what they're used for. You'll have heat sinks, lubricants, aerospace components. So just wide varieties and just how they're just used very broadly. And just a lot of the uses you can get from them. You'll have lastly boron carbide, which will include ballistic armor, abrasive materials, cutting tools, and also some aerospace components such as shielding. Why carbon can be considered a ceramic? Containing of inorganic metallic oxide, nitride, or carbide composition, very similar compared to just ceramics in general. Ceramics, as previously discussed, are known for their brittleness, hardness, and strength and compression, which are typical properties of carbon-based materials. Additionally, ceramics are strong in compression but weak in shearing and tension, which is just another characteristic of carbon. The chemical durability of ceramics against the effects of oxygen, water, acids, etc., along with their thermal electrical conductivity, which are also properties of carbon, which contributes to the classification of carbon as a ceramic. So chemically inert, their resistance to corrosion and chemical attack, which makes them relate to traditional ceramics used in harsh conditions. It kind of exists in solid organic forms such as diamond and graphite, but carbon structures are held together by strong covalent bonds, which is a key characteristic of ceramics. So you'll have your manufacturing processes of carbon ceramics. These are the steps in order to achieve the final result. So you'll have material preparation. It's a process that begins with carbon fibers, which are cut into short sections and given a protective coating. Those fibers could be used directly or treated to complete a complex raw material known as a carbo chip. In that preform creation, those carbon fibers, which are woven into a 3D fabric to form a preform. The preform serves as a base material for the brake disc and is created through a needle punching process that interweaves multiple layers of the continuous fiber cloth. Which will then go into the chemical vapor infiltration, also known as CVI. This preform undergoes the CVI process where the reactant gases are introduced into the porous structure. This step allows for the deposition of materials that fill the spaces between the fibers, forming a composite material. You'll then get into heat treatment. The preform is then subjected to a heat treatment process at approximately 3,000 degrees Celsius. This step eliminates non-carbon elements and rearranges the atomic structures into highly ordered and dense crystalline form, enhancing the material's strength and stability. Siliconization, following the heat treatment, is a reactive melt infiltration RMI process is employed. In this step, the molten silicon is infiltrated into the carbon-carbon material, resulting in final composite material known as carbon silicon carbide. This process is crucial for achieving the desired properties of carbon ceramic material. And then finally, you'll have your final machining. After that silicon carbide has been infused, the brake discs undergo final machining. So this step is necessary due to the hardness of the material, which requires the use of diamond tools for precision shaping and final touches, finishing, that kind of thing. Which ultimately gets into my final product, carbon ceramic brake discs. And it's just ultimately was a technology that was born in the crucible of Formula One racing and is now available on a range of elite vehicles, some higher end vehicles, from the McLaren and Porsche to BMW and Ferrari. It offers a far more advanced solution than traditional cast iron. They're extremely heat resistant, so unlike your iron rotors, which can suffer from brake fade during repeated, like heavy braking, carbon ceramic rotors are designed to handle incredible temperatures without losing performance. So they're kind of more designed to be lifelong, like they can under like normal just like street use, majority of the time they're designed to last the longevity of the car itself. So in that case, you'll save a lot of money kind of down the line. In my next slide, there will be some graphs and things like that that'll kind of break up just the differences and kind of highlight some of the key things as to why they're in the long term a little bit more beneficial than just your traditional cast iron rotors. They're extremely light compared to the cast iron rotors. There's a lot of weight reduction, which sometimes they can weigh up to literally half the amount of just your traditional rotors, and this dramatically will improve the handling of the vehicle, the steering feel, and just the ride quality overall. And yeah, they're just, like I said, they can get on the pricey side. This next slide, this one here will kind of break down at least the costs and things like that. I know on the higher end vehicles, such as like BMW and higher end like Audis and Mercedes, AMGs, things like that, that will have carbon ceramic brakes equipped. I mean, just the package alone is like close to $10,000. But you ultimately, in the longevity just of getting the car itself is, I guess, a good thing if it's if you look at it through the long term, long use point of view. But yeah, some of these graphs will just break up. So depending on the rotor diameter, the weight will vary heavily compared between the two. You'll have this weight kind of scale comparison up here on the right, showing you that, I mean, the carbon ceramic brake is literally less than half the weight of the steel disc. You'll have some of the price down here at the bottom right too. Like I said, that just kind of highlights some of the long-term use of the ceramic brakes and just kind of over a 50,000 mile interval, the difference in maintenance between the two. Obviously your pads and things like that you can't get around, but improving the rotor and just the quality of it in general will in the long term, reduce the cost of how much you spend in maintenance towards that kind of thing. And then this last slide here would just be my works cited and ultimately where I just kind of got a majority of my information from. And yeah, that'll be it for my carbon-based ceramics PowerPoint. Hope you guys enjoyed. Feel free to leave a like and subscribe.